In the previous video, we built the probability distributions of first rolling one die and then rolling two dice. And we laid out kind of how to structure from the results into the actual probability distribution in the graph. And so next I want to discuss additional ways to summarize these likelihoods, right? And so we're going to roll a die. We don't know where it's going to occur or what outcome is going to result, but we have a sense as to the likelihoods of various results. And we can go a little bit further and talk about things like the mean and the standard deviation or the variance. And so we're going to do that here with these two scenarios. So the mean of the probability distribution is what we're after here, and it right away it looks a little different, maybe a little scary. We're incorporating some new kind of aspects into our mean calculation, but let me tell you that it's the same process that we've been working with mean in the past. Okay, so the mean is when we first learned mean, we added up all of the x's and we divided by n, right? And we're doing a very similar thing here. And so it's just the way we, and in fact, this is most closely related to the grouped mean calculation. And so in an additional video, we'll walk through kind of both of those at the same time and highlight that they really are doing the same thing. So let's set that concept aside for a moment, and we're just going to go ahead and use this equation and calculate the mean of our single die roll. Okay, so just to reiterate or to refresh, remember we had we can even just rewrite that. Actually, maybe I can just grab it. See if all my technology is doing here. Let's copy that. Well, that's pretty good. That's pretty good. Mess ups. All right. So here we have our probability distribution. How do we take and learn or calculate the mean of this? Well, we simply want to follow this formula and say the mean is the sum of the x's times the probability of x. And here we have our x's, so our sum here is really our x, and here we have the probability of x. So set aside the summation and the shortcutting here, what we're really doing is 1 times 1/6 plus 2 times 1/6, where 1/6, in this case they're all 1/6, but really we're taking 3, and what's the probability that a 3 occurs? Well, that's 1/6 plus 4 times 1/6 plus 5 times 1/6 plus 6 times 1/6. Okay, and that's going to spit out the mean of these, right? So in this simple step, we're kind of combining the summing up and the dividing by n all at once. And one way to potentially might be helpful to visualize it in the sense of doing this many times and multiplying. Well, we'll leave that for the summation video, or the grouped summation video. Grouped mean is what I'm trying to say. So here we can spit out, this is going to be, well, why don't we, at the same time, we could think about doing this I'm going to change colors here just to note. So this is going to be x times p of x. Just going to calculate this out in kind of a chart form. Now you don't obviously have to do this every time, but maybe it'll be instructive. So 1 times 1/6 is going to be, so this is, just back up and do it. So 1 times 1/6 is 1/6. Okay, 2 times 2/6 is 2/6, and I'm going to keep it general here because I'm going to want to combine these, right? I'm going to want to sum these up at the end. So 3 times 3/6 is 9/6. So I've already made a mistake twice. Well, let me back up. Check your error. Okay, so 2 times 1/6 is 2/6. Things are going to balloon out of hand there quickly. So there's only a 1/6 chance that we get a 3. 4 times 1/6 equals 4/6. And when we add all of this up, then we will have our mean. Okay, and then lastly, 6 times 1/6 is obviously 1, or 6/6. Okay, so now that's me basically combining all of the blue over here, and so we can add all these up. We get 1, 3, 6, 10, 21/6. So this is 21/6. This is also going to equal 21/6. Okay, or 3.5. Okay, so the mean of a single die roll is 3.5. And again, we probably could have got there with some kind of logic as far as, that's halfway in the middle, or because it's evenly distributed, or just from thinking about, okay, a 1 and a 7, put that together, half is 3.5, 2 and a 4, 3, or 2 and a 5, and 3 and 4. Anyway, multiple ways to contemplate this, but this method of simply taking the x's and multiplying times probability is going to give you the mean every time. Okay, so that's the mean. What about, well, actually, let's turn and we've also dealt with the 2 die roll. Okay, so a little more complicated, but the process remains the same. So let's grab this again. And we will see where we are on the screen. Let's grab. Okay, so again, to calculate the mean here, let me just switch colors over. So mean being the x times the p of x, and so we could think about it in the table, or just writing out the formula. We would have, this would be, so this is x times p of x. Just get rid of this mean thing. And that's going to give us, there's the chance of a 2, but there's only a 1 in 36 chance. There's a chance of a 3, and that's a 2 in 36 chance, and so on, right? 4 is 3 in 36, and so on. And so we would do that all the way down, and sum those up, okay? Or we could think about the mean and just simply writing out the sum of x, p, x. And if we again wanted to kind of display that, it'd be the same. It'd be 2 times 1 over 36, right? The p of x there, plus 3 times 2 of 36, and so on. Now, I'll let you verify this, but the mean is going to spit out as 7. Okay, and so there's a variety of ways to think about why that's true. Again, it's kind of in the center of a symmetrical display, but also independently, each of these is a single die roll, right? So again, this is unique to kind of this type of a situation, but this occurs quite often when we're dealing with this type of classical probability, is that we can build these kind of concepts outside of just the equations as well, right? So we have 2 dice being rolled, and so each of those by themselves has a probability of, or a mean of 3.5, and so together they have a mean of 7. But you can verify that with plugging out this number, or hacking through that the math here, but you'll get a mean of 7. And so that again gives us a sense as to, okay, I'm going to roll a couple dice. They're going to average, a mean of 7 there. And again, we probably could have expected that, but what if you're rolling 5 dice, and what's the mean going to be? And in fact, it's, what is that? 17.5. Did I do that right? 15? Yeah, 17.5. So we'll be back with a video on the variance and how we can quickly calculate that and incorporate that into our discussion of the spread of our various outcomes.